and we'll get into this. Um, there are a couple of different valid solutions to this. The first time I taught this, I had students writing something that looked very different from what I did. And I was like, oh, I guess you could do it that way. So I'm curious, how many people wrote for part A something that looked like this? Anybody do that? Okay, did anybody do anything different? What did you do? You did, oh, just having it facing the other way accidentally. Did anybody do this? No? So this is how I saw it at first, but usually I have one or two students who will see it this way instead. When you look at something in the mirror, it's reflecting it, right? You're kind of making a reflected image, and it kind of depends on where your mirror is, right? If your mirror's below it, and you've got your mirror sitting like this, you're going to see something that looks like this. And if it's to the side, you're going to see something that looks like this. So, what did you notice about wow? It's the same. Does anybody know the vocabulary word? It's an English vocabulary word for a letter that's spelled the same forwards and backwards. Do you remember what is it? Palindrome. Does that sound right? And then there are special types of palindromes where if you look at it in a reflection, it looks the same too. Wow is one of them. What's another one? You guys know any other palindromes? Mom is another one, yeah. Kayak. Dad. Race car is my favorite. Race car comes out the same. Cool. All right. So we're going to be messing around with reflections today. This next one is more of an imagination thing. So imagine I've got a flag that's on a pole, and the flag is triangularly shaped. Actually, I've made one. I tried my best to make one here. If I take this and I spin it around really fast, it's hard to see in there, but if you look up here, if I spin it around really fast, what three-dimensional shape would we end up with? And in this space it's provided, you can either draw a picture of it or just write the name of it. So if I took that flag and spun it in a circle really quickly, what would it look like? It would be some kind of 3D shape. And there is a name for it. Yeah. Oh, I like your drawing. You got like shading and lighting in there and everything. Nice. Anybody know the name of that shape? It's a cone. Yeah. Looks like an ice cream cone. I think I got one of them here somewhere. Maybe not. All right. So it would be a cone. You could either write the word cone, or if you're feeling artistic, go ahead and draw one. I'm going to try my best to sketch a cone here. It would have a base that would be circular. You wouldn't actually be able to see that little part back there. What if we wanted to design a different flag so that when we spin it, it looked like a sphere, the shape of a basketball? What would that flag need to look like? So go ahead and draw it. Draw your flagpole and draw what your flag would look like in order to get that. So this time we're trying to get something that's the shape of a sphere. What shape would our flag need to be? I'm seeing... Did you draw one? Put some down. Make a guess. Make a guess. I want it to look like a ball. It's something... So it's some flat shape that if I spun around, it would look like a ball. Can someone describe it to me? Kind of looks like a P. Okay. A half circle. It does look like a P. A half circle. Does anybody know the technical name for half a circle? Semicircle, yeah. Semicircle. Did anybody draw a flag that looked like this? Would that also create a sphere if you were to spin it around? It would, yeah. You're going to find in this class there are a lot of correct answers to some of these questions. All right. The diagram at right shows the result of reflecting a snowman across the line. Why do you think it's called a reflection? I'll let you ponder that quickly. How is the image different from the original? So we're going to get into some technical stuff in our next couple of lessons. I'm going to actually switch the question here. Let's do a little compare and contrast. What is the same about these two pictures? They're both snowmen. So in terms of what we're going to get into next, you're saying they're both snowmen. I'm going to say they're the same shape. Everything is the same shape. Would you agree? They both have a snowman shape. What else is the same about them? They're the same size, and those are two key concepts that we're going to see a lot in this first chapter. Same size and same shape. The thing that's different is they're facing different ways, and in geometry we call that the orientation. So the way it's pointing is different. So same size, same shape, pointing in a different direction. Go ahead and flip over. We are going to practice doing some reflections. Now, many of you are going to find, so there's something we need to pause and talk about for geometry. There is a spatial visualization skill that we're going to be using a lot in this class. And some people have a very highly developed spatial visualization skill. Usually people who are really interested and involved in visual arts are pretty good with this, but it's the idea that, like, can you take something and look at it, and in your mind, can you see what it would look like if I spun it around, if I flipped it over, if I made it bigger, if I made it smaller? Some people can actually see that image in their head and mess around with it, like in an imaginary way in their head. And for some of us, that's much more difficult. So when we start working on stuff like this, and I can already see some of you are already halfway done or closer than that, some people are going to find that this goes really quickly. Some of you are going to find that this is a little bit more challenging for you. Does that make some of us smart and some of us not as smart? Not at all. Not at all. Our brains all work differently. So be kind to yourself. If somebody sitting near you is struggling, be kind to them and give them some hints. Can I get everybody's attention up here really quickly? I want to show you something that most of you probably don't need to see for this one, but you're going to need to see when this gets tougher, okay? Please give me the opportunity to give you a tool that you are going to need when we get to some much more difficult problems later on. A lot of you probably have already finished number one. I want to show you how to use the tracing paper to do this if we get to something tougher, okay? So I know that you may have it done already, but let me just show you how. Take your tracing paper, please. Please try and just use like the corner of it, because again, we're going to try and use this tracing paper for a couple different lessons. I'm going to ask you to go ahead and trace the dashed line and to trace the figure. And this is going to work better if you have a pencil for a couple different reasons. Trace the line and trace the figure. I'll give you a moment to do that. Now, when we do a reflection, what are we going to do with our tracing paper? We're going to flip it over. We're going to flip it over. This line's going to stay in the same place, but we're going to flip it over. Now, I need to just transfer this onto my paper. If you wrote in pencil, you can probably just run your pencil over that line again, and it will rub some of that pencil lead off onto your paper enough that you can then go back and make it darker. The other thing that you can do is, if you're using a pen, you can get it lined up and then sort of sneak your pen underneath the tracing paper and draw points. There's a point here, there's a point here, and then go back and connect those dots. Okay? So I'm going to ask you guys to go ahead and do the reflections. I will say that number 3 and number 4 are the most challenging for my students to do, especially if they're trying to do it without the tracing paper. There is one on here that about 90% of my students get wrong on the first time. 90%. So I'm interested to see how we do. If you finish with that, just kind of pause for a second, check in with your neighbors and see if they can use some assistance. I'll be around to answer questions. So I always anticipate some struggles with number 3 and number 4. I talked to a few people that were doing everything correctly, but they were trying to do the reflection with the tracing paper, and they weren't drawing the line. And it makes it a lot tougher to get everything oriented in the right place if you don't draw this line also. So make sure you draw the line of reflection. When you flip it over, make sure that line matches up with the original line of reflection. And then you can just kind of transfer that. So we should be looking something like that for that one. And then number 4 is the one that my students most commonly have the most mistakes on. So I'm going to do with my paper, and I'll draw my line, and then I'm going to flip my paper over, make sure the line matches up. Did you guys have something that looked like that? Now this one's kind of weird because it actually ends up overlapping with the original shape. That's what that reflection would look like. I had some good questions as I was walking around. A couple of people made a connection with symmetry. You guys learned about symmetry probably back in like elementary school. Can you see how, if I kind of turn this so that this line of reflection is vertical, can you kind of see the symmetry between the two sides of this? That's a clue that you're doing something right. And a lot of times, if you make a mistake doing a reflection, you'll be able to spot that mistake because like this seems like it's not quite symmetrical. Same thing with this one here. If I kind of turn it, it's easiest for me to see if I make it so the reflection's up and down. I can imagine folding this paper across this line and these two things would match up with one another. Several of you pointed out that 6 was interesting because why? It's the same, right? If we reflect it, we get the exact same thing. I also had a great question about number 4. One of you asked, isn't that a rotation instead of a reflection? And the answer is, it is a rotation and a reflection. And we're not doing rotations today, but I'll just give you a little preview. There's my original. When we rotate, we will rotate around a point, and I believe it would rotate around, not that one, yeah. If I rotate it around this point, we get the other rectangle. So yes, it is a reflection, and it's also a rotation. So awesome connections that people are already making. If you have questions about 2 and 5, let me know. I feel like most of us are probably feeling pretty good about those. Let's go on and finish this up. Some of you have already looked at the bottom. We've got several images here. I would like you to identify which ones are reflections and which ones are not. And as an extra challenge, can you name the other transformation? A transformation is something that we can do to one shape to make another version of it. The only one that we've learned in this class so far is reflection, although I just mentioned rotation. See, I know that you guys, that this does come up in middle school math as well. See if you can remember the names for the other ones. Ooh, that's one that we don't get to till second semester. There's one that starts with a D. What's the one that starts with a D? It makes things bigger and smaller. A dilation, have you heard of a dilation? Any of you ever go to the eye doctor and you get your pupils dilated? They put drops in there and it makes your pupils really big. It dilates it, it makes it bigger. Reflection, it looks like A is a reflection. Do you agree? Is A reflection? I don't think B is because that doesn't look symmetrical, but we could get from here to here by doing what? That's a rotation. Is C a reflection? No, it's just kind of been moved down. Do you remember what we call something when we just slide it? Nice, yeah. Can you say it louder? Translation, does that sound familiar? This would be a translation. Some people call it just a slide. And then D, reflection. Yeah. Do you see it as a reflection? I think D could actually be, could have two answers. Yeah, I think we could make it a rotation. I think the point of rotation would be up here someplace. If I spun that around, I think I could get them to match up into the same split. We're going to mess around with rotations with the tracing paper later on. So if you guys would turn back to the front of your packet, just make sure that we hit our learning targets for today. Do you feel like you got an opportunity to use your spatial visualization skills and that you have had a chance to investigate reflections? All right, wonderful. We'll call it a win then. And let me get your assignments out to you. My goal was to provide